All right, so we're starting this section on factoring. So this is technically review for us, but we need to make sure that we got a solid understanding of factoring before we try to go into solving quadratics and solving polynomials. So we're going to solve trinomials of this form. So x squared plus bx plus c. So notice this has a coefficient of 1. So that's what's going to make this important, because 4.5 is when we're going to have a coefficient that is something that's other than 1. So what we're doing is kind of like reverse FOIL method. So FOIL, remember that's your first. So your x's were first, you get x squared. Your outers, so your x times that 5, you get 5x. Then your inners, so then your 2 times your x, your 2x, and then your last, your 2 and your 5. So what's important to notice here is that this was the product of that 2 and that 5. Actually, let's use these two down here. That's the product of the 2 and the 5. Then the 7 here, as we see, was also came from that 2 and the 5, except this time it was the sum of that 2 and that 5. So knowing this information, this middle term is a sum of factors, and then this last term is this product of factors, or product of numbers. They are the same numbers. So this is something we know that we're going to use to go backwards to help us factor instead. So we want to basically reverse a FOIL. So as I was saying here, the last term 10 has to be the product of the last term of the binomials. And this middle term is a sum of those last ones. So kind of what our plan is we want to say if we wanted to factor x squared plus 7x plus 10, we already know what it factors into, but let's say we wanted to factor it. What we need to do is find two numbers that are factors of 10. And we need to find the such factors that if I add them together, they would give me back the 7. Once we find those two numbers, then that would be the factored form of x squared plus 7x plus 10. So like I said, we would have to pick numbers p and q must be selected, so their product would be 10 and then their sum would be 7. So that is what we're going to work on, and it's not really that complicated. Well, basically we just need a chart and some trial and error. So for example, we want to factor x squared plus 10x plus 1, or plus 21, sorry. So what we want is a pair of factors. So these need to be factors of 21. And what we want to do, make sure is this sum of factors, we want to make sure that they sum to 10. So basically what we're looking for is factors of C and trying to find products that give us that B in the center. So looking at 21, well, we know some factors. We got 1 and 21. We got 3 and we got 7. There's also negative factors to consider. However, in this case, we're really not going to need them. But always bear in mind that when you have a positive number, either its factors are going to be two positive numbers or two negative numbers. But if we add these up, 1 plus 21, well, that's 22. 3 plus 7, that's 10. Negative 1 plus negative 21 is negative 22. Negative 3 plus negative 7 is negative 10. We had a positive 10. So what we're going to want are these factors. So what this tells me is that if I want to write how the factored form of x squared plus 10x plus 21, we're going to have the x's. What this tells me is what these remaining numbers are going to be. So one's going to be 3 and one's going to be 7. And you can always like double check that. So x times x is x squared, x times 7 is 7x, 3 times x is 3x, 3 times 7 is 21. So it looks like we did get the correct factors. So it's always good to like check afterwards, do FOIL again to make sure that what we did was correct. All right, so on your worksheet, attempt to do number 1. So it's x squared minus 12x plus 20. And number 2, I have to correct one thing. That was supposed to be a negative 5x in there. But my dyslexic brain made it a 2. So like I said, do rewrite this one as x squared minus 5x plus 4. All right, so for number 1, we were looking for pair of factors. So try to get a different color here. A pair of factors of that 20 that give us the negative 12. Or that sum to the negative 12. So we have the choices of 1 and 20. We have the choice of negative 1, negative 20. We have a choice of 2 and 10. We have the choice of negative 2 and negative 10. And we have the choice of 3 and 4. Oh, 10. Sorry, that should have been 6. No, 20s. I'm doing 20s. Sorry, I was looking at the 12 suddenly. 5. I need the 5. So the other one would be 4 and 5. Or negative 4, negative 5. All right, that's why be careful what you're looking at. So if I add these up, that's going to be 21. If I do the negatives, well, as you see, that's going to be negative 21. If I do the 10 and the 2, that's going to be 12. Almost have what we need. If I do the negative 2 plus the negative 10, that gives me negative 12. So I don't need to keep going. I already found it right here. Those are the two numbers. They're factors of 20 that also sum to a negative 12. So we can split this up into x minus 2, x minus 10. All right, so for negative 2, like I said, changed it to x squared minus 5x plus 4. So once again, one of the things to consider here from the last one is that, or the last two, was the first one that we had, the example, was that this was positive, and we wanted this to be positive. So we ended up with positive numbers. This is positive, but this is negative. So I have to sum two numbers together to give me a negative. And I have two choices for my factors. Either two positive factors or two negative factors. So we'll put this on another slide here in a bit, but my way of doing this would be, I may want to look at my negative factors of 4. So that would be negative 1, negative 4, negative 2, negative 2. Well, if we sum up negative 1 plus negative 4, that is negative 5. If we sum negative 2 plus negative 2 plus negative 2, we get negative 4. So we didn't want them to sum back to 4. We wanted them to sum to that negative 5 in the center. So this one's factors would actually be x minus 1, x minus 4. So if we have our constant terms, we're talking about that c. oops, sorry, we don't have the a in this case. X squared plus bx plus c, this is the constant. So if that constant term is positive, that means that when we're looking for factors, our factors need to be able to produce a positive number. So either both factors are positive or both factors are negative. If the middle term is negative, then both factors will be negative. If the middle term is positive, then both factors will be positive. So that's what I was saying for number 2, was that I already saw the middle term was negative. My constant term was positive. I knew I was going to need 2 negative numbers. Like I said, if you're a little unsure about that, it's just a way to help you kind of eliminate some factors to look at. You can still just look for every pair of factors as a way to do this. Oops, so work on number 3, and then we're going to talk about what happens when we have a negative constant. All right, so we need a pair of factors that give me this c, or the negative 20, and the b in the center, what they need to sum to is negative 1. So to get a negative 20 means that when I'm looking at a pair of factors, 1 and 20 won't cut it, but 1 and negative 20 would multiply to give me negative 20. That also means negative 1 and 20 would also be a pair I have to look at, because they also multiply to give me a negative 20. We'd have to look at 2 and negative 10. We would have to look at negative 2 and positive 10. We would also have to look at negative 4. Or no, we're going to do 4. 4 and negative 5, and negative 4 and 5. So if we add, so 1 plus negative 20 is negative 19. Negative 1 plus 20 is positive 19. 2 plus negative 10 is going to be a negative 8. Negative 2 plus 10 is a positive 8. 4 plus negative 5 is a negative 1. And negative 4 plus a positive 5 is a positive 1. And we wanted them to sum to that negative 1. So this is what we needed, was that sum, or that product right there. So this would end up breaking into x plus 4, x minus 5. The constant term of a trinomial is negative. We have to look for 2 factors whose product is negative, meaning when we look at those factors, one has to be positive and one has to be negative. If your middle term is negative, that would mean that the bigger of the factors is negative. And if your middle term is positive, that would mean the bigger of your factors is positive. So this was just kind of sort of a way to talk about, put your rules together, make it concise. You always want to arrange in ascending order of the power. Arrange in descending order of the power. I should have said power there. So what they mean is that you want to make sure that x squared goes first, then the x, then the term without the x. You want to use trial and error procedure to look for factors of c whose sum is b. We said if c is positive, then the sign of the factors have to be the same. They're either both positive or they're both negative. If c is negative, then one factor will be positive and one factor will be negative. And then we just check our results with multiplying. So all you guys have to do for now is go through these few problems. So 4, 5, and 6. I just want to mention this x squared and this y squared. Don't worry about the x's and y so much. Just know that when you do this, I'll say it's a negative and a positive, you're going to have a negative that's in front of this y. That's what you're looking for. Because then when you FOIL this, then you're going to end up with an x squared and a y squared and an xy in the center. So really just focus on those factors of the negative 28 that sum to negative 3. So factors of negative 28. Well, we'd have -1 and 28. You'd have 1 and negative 28. If we do the sum of that first one would be 27, and the other one would be negative 27. We could do 2 and, or -2 and 14. That would sum to 12. You can do 2 and negative 14. That would sum to negative 12. We'll see what we're missing here. 7, I think, is my only other one. 4 and 7. So if we do -4, then we would have 7. So the sum of those would be a +3. And then if I do +4 times -7, because those both sum to negative 28, that will give me a -3. So there I have my factors. So like I said, with the x's and the y's, that means that you're going to have an x plus 4y, and then you're going to have an x minus 7y. Because when we FOIL this, we get x squared plus 4xy. Then we're going to get, oops, I did that the wrong way. It still works. It's just not actual FOIL. And then we have 4y to the x. And then we multiply on the outside, and we end up with a -28y squared. So what you're looking for here is that you have the variable squared at both ends, and then we just have one of each variable in the middle. That means I can break it up like this. So this one also has a little trick to it. So I have to write these in order of power. And the problem is we have this negative out front. So when we want to get rid of a pesky negative, what we're going to do is essentially like factor it out. So if I factor out a -1, it's kind of like you divide everything by -1, we get x squared minus 2x minus 24. So this part right here is the part that we want a FOIL. So we need factors of -24. And we need those factors to sum to that -2. Sum of factors, there we go. So I'm not going to use the 124. We already can pretty much see right away that's not going to work. Let me see. If we did 2, then we'd have 2 and 14. That's not going to work. If we do I said 2 and 14. I'm sorry, 2 and 12. I'm sitting there going like, where is this 14 coming from? If we divide by 2, we get 2 and 12. So you like, in this case, you might want to start picking something. Numbers that are a little closer together, because we've got a negative in here. So when these numbers sum up, we want them to be -2. So you can kind of reason your way through this a little bit. So -3 and 8, the sum of those is going to be a +2. If we do 4, -4 and 6, those sum to a +2. If I do +4, -6, that sums to -2. So those would be my two factors. So you're going to keep this negative out here. We're just going to leave it like this as a negative. We know that represents a -1. So you leave it out here, and then our factors would be the +4, so x plus 4, and then the -6, x minus 6. So alternatively, you may pull that negative into one factor. So you may have also seen a negative x minus 4 times x plus 6. Or you may have saw a x plus 4, and then you would have seen these would switch, so you'd have a positive 6 minus x. So those are alternative ways you might actually have seen this as well. But when we went completely factored, we'd pull out that negative for the most part. And then 5 had one little trick to it as well. So you may have noticed that we can't factor this one. So you can't always factor a trinomial. Sometimes it's just not possible. So factors of 6 are 1, negative 6, that sums to negative 5. Or negative 1, positive 6, that sums to positive 5. Or we have 2, negative 3, that sums to negative 1. And then we'd have negative 2 times positive 3. The sum of those would be a positive 1. I ran out of factors of 6. I have 1 and 6 and 2 and 3. So what we have here is this one cannot be factored. And when it cannot be factored, we call this a prime trinomial. So what it means to be a prime trinomial, there we go, is that we cannot factor so that we have rational numbers as your factors. This still can be factored. This is something we would see a little later. You can use quadratic formula for that. But as is, you cannot factor this and still maintain rational numbers. So by rational numbers is anything that's a whole number, a negative of a whole number, 0, or a fraction. So a prime trinomial is a trinomial that cannot be factored over the rational numbers. Rational numbers are integers and the ratios of integers. So you get like negative 2, negative 1, negative 3, 0, 1, 2, 3, or you could have like 5 over 2, negative 2 over 15. We weren't seeing those kind of numbers for our factors yet with the fractions, but it is something that could happen.